This is a quick introduction to complex numbers. I is defined to be the square root of -1. So every time in the past when we have said that you cannot have a negative underneath a radical, well, now that is no longer true, because complex numbers will deal with negatives underneath the radical. A complex number has two parts. It's written in the form a plus bi. For example, 3 plus 2i, or 4 minus 11i, or 5, because I can write that as 5 plus 0i, or even just something like 6i, because I can write that as 0 plus 6i. So the two parts are a real part and an imaginary part. Let's look at an example of simplifying a radical. So simplifying square root of -36. I can rewrite this radical as the square root of -1 times the square root of 36. Square root of -1, remember, is defined to be I, and the square root of 36 is 6. So this is I times 6, or just merely 6i. So the square root of -36 is 6i. Okay, let's look at a second example. The square root of -72. Again, I can rewrite this as the square root of -1 times the square root of 72, which is I radical 72. And this first step, I'll sometimes say or ask you to take your i's out. Now, let's simplify this radical 72. The largest perfect square factor of 72 is 36. So I can write that as the square root of 36 times 2. I still have the I out front. And then I can break apart the radical into the square root of 36 times the square root of 2. Now I have I times 6 radical 2. And that's not wrong, but you will usually find the I placed in between the 6 and the radical 2. So usually the I will go right in front of the radical, so it doesn't get lost. Okay, we're going to look at a few simple operations. So for example, 4 plus 7i plus -3 plus 6i. Well, all you need to do is combine the like parts. So look at the two real parts, the 4 plus the -3, and add those. 4 plus -3 is 1. Then look at the imaginary parts, 7i and 6i. 7i plus 6i is 13i. So my answer to this problem is 1 plus 13i. Let's look at a difference. If I take the same complex numbers and find their difference, 4 plus 7i minus -3 plus 6i. First, find the real parts, 4 and -3. 4 minus -3 is like 4 plus 3, so that becomes 7. 7i minus 6i is 1i, or just plain old I. So the difference for problem number 4 is 7 plus I. Let's look at some simple multiplication. So first, something like 6i times 2 plus 5i. Well, I'm just going to distribute. 6i times 2 is 12i. 6i times 5i is 30i squared. Okay, but now it doesn't stop, because I squared can be simplified. Remember, I was the square root of -1, so I squared is -1. So now let's substitute that in. I get 12i plus 30 times -1, or 12i minus 30. And because complex numbers are written with the real parts first and then the imaginary, I would normally rewrite this as -30 plus 12i. Okay, another multiplication. This time two complex numbers of the form a plus bi. So 10 plus 3i times 4 minus 9i. We're going to FOIL these like we would just normal binomials. 10 times 4 is 40. 10 times negative 9i is negative 90i. 3i times 4 is 12i. 3i times negative 9i is negative 27i squared. Begin by combining like terms. So 40, and then negative 90i plus 12i is negative 78i. And then negative 27, remember I squared can be replaced with negative 1. This is 40 minus 78i plus 27. Let's combine our like terms. 40 plus 27 is 67 minus 78i. So our product is 67 minus 78i. One final example. So 3 plus 5i times 3 minus 5i. Now notice, the real parts are the same. The imaginary parts are the same, just that one has a plus and one has a minus. These types of complex numbers are called complex conjugates. And something interesting happens when we multiply them. 3 times 3 is 9. 3 times negative 5i is negative 15i. 5i times 3 is positive 15i. And 5i times negative 5i is negative 25i squared. Combining like terms, my i's cancel out. So I have 9 minus 25. Remember, I squared can be replaced with negative 1. So this becomes 9 plus 25, or 34. So we just multiplied two complex numbers and ended up with just a real number. That happens every time you multiply complex conjugates.